We are going to practice balancing half reactions, and while we're doing that, we're also going to practice what's oxidized and what's reduced, just to give you some more example problems. I tried to do a different variety. At any time, feel free to pause the video, do the problem yourself, and then come back and double check what's going on. Okay, so in each of these problems, we're going to label each of the following half reactions as either oxidation or reduction, and then we're going to write an overall balanced redox reaction, and we have down here the little 3 viewpoints for oxidation and reduction, and below that I have put the steps to balance different equations. Okay, let's go ahead and get started. So first of all, let's determine what's oxidized and what's reduced. So in this situation, we don't have oxygen or hydrogen. So let's go ahead and assign oxidation numbers. So right here, when we have a monatomic ion, the oxidation number is always what the charge of the ion is. When elements are by themselves, we call this their elemental form. That also applies if it's a diatomic molecule, aka Brinkelhoff. And these are going to be 0 because they have the same atoms. So iodine, same atoms. If we have 2 of them, they have the same electronegativity, so they're going to have a 0 oxidation number. Go over here, chlorine's in its elemental form, it's a 0. Over here, -1, it's an ion. Okay, so now let's double check things. -1 to 0, we have an increase in oxidation. If we have an increase in oxidation, this means oxidation, and that's because we are actually losing electrons. Okay, when things become more positive, we're losing something that's negative. Okay, on the chlorine half reaction, we're going from a 0 to -1. Here, the oxidation numbers are decreasing, or being reduced, as I like to call them. And so this is showing reduction, and reduction is the gain of electrons, because if we gain something that's negative, it's going to become more negative. Okay, so that's our oxidation and reduction. Now let's go ahead and balance this. So let me clear some space for us. Okay, the first thing we're going to do is balance each half reaction, their atoms and their charges. So let's go ahead and do this iodine. We're going to do, actually I'm going to erase all of that because I think it will look better. Okay, now let's go ahead. So right here we've got 1 iodine, 2 iodines. We're going to put a 2 in the front. Now we have a 2 as our coefficient and a -1. Remember, when we're doing these balancing, we have to multiply. So this overall has a -2 charge. Over here, we have an overall of a 0 charge. There's no charge. So remember, we're going to add electrons to the side that is the most positive, and we add however many electrons we need to get to the same charge as the other side. So in this case, 0 is more positive than a -2. So we're going to add 2 electrons. So now -2 and a -2, those are equal as far as their charges go. Okay, now let's do chlorine. We have 2 chlorines on the reactant side, only 1 on the product side, so we're going to go ahead and put a 2. On the reactant side, no charge. On this one, we have a 2 and a -1, so that makes a -2 when we multiply. Again, we add electrons to the side that is the most positive. We need it to match a -2, so we're going to add 2 electrons to the reactant side. Sorry, that's kind of smushy. So I'm going to rewrite these. So right now we've got 2 iodine that are negative. That goes to iodine. It's a -1 charge. And 2 electrons. Then for the chlorine, we have a Cl2 plus 2 electrons on the reactant side, and that goes to 2 chloride ions. Okay, notice how I put them together now. I've matched up, I haven't put them together, sorry, I've matched up the arrows. So now what happens is we want to make sure that the electrons are the same. So we have 2 electrons on that half reaction and 2 in this one. So they're the same, so we don't need to do anything. We just need to cancel them out. So I'm going to go ahead and cancel those out, and then we bring everything down. So on the reactant side, we have 2 iodide ions plus 2 chlorine atoms. Then we have 2 iodine atoms and 2 chloride ions. Okay, now that we put it together, now we need to make sure that the atoms and the charges are the same on both sides of the reaction. So let's go ahead and double check here. So we've got 2 iodines, 2 iodine, 2 chlorine, 2 chlorine. Our charge over here is 2 and a -1, so we have a -2. There's nothing on the chlorine. Over here, nothing on the iodine, a 2 with a -1, so a -2. So this would be our overall balanced redox reaction. If there's anything wrong as far as number of atoms not matching on both sides or the charges aren't the same, then go back to the first part and redo it again. Okay, let's do another example. Okay, this one looks kind of scary. This is actually part of number 27 in your book, but I thought it was one that we should go over. So on this one, if I ever give you anything like this on the test, I'm going to give you a hint, such as compare the underlying substances and look at the oxygen, not the hydrogen. Okay, and that's because this one is kind of tricky. Now, whenever you see a problem like this and there's multiple substances, it's probably because the hydrogen ion and the water are just for balancing purposes to make this reaction work. Because later on in your chemistry career, you will do redox reactions again, but you'll do them for acidic and basic solutions, and they're actually a little more tedious, and you have to add in the hydrogen and the water, or you have to add in the hydroxide ions if it's basic. So that's where these are coming from. Okay, our job is just to put it together and make an overall reaction. Okay, first thing, let's again decide what's oxidized and what's reduced, which half reaction is what, and then we'll put together. Okay, we're going to look at the underlying substances. So right here, nitric acid is underlined, and we're looking at the oxygen. So here we have 3 oxygen. On nitrogen dioxide, we have 2. So this is showing a loss of oxygen. A loss of oxygen means reduction. Okay, so this half reaction is reduction, this whole thing. Okay, this half reaction, let's go ahead and look at this one. On this one, we have 2 oxygens. On this one, we have 4. So we're showing that we have gained oxygen, and gaining oxygen is oxidation. So this half reaction is oxidized right here. This half reaction on the left, this one is reduced. Okay, that's how you tell what's oxidized and what's reduced. Now let's go ahead and let's balance this. Okay, so first thing, balance the atoms and charges for each half reaction. So right here, remember we're going to still skip hydrogen and oxygen to be the very last thing. So right here we have nitrogen, we have 1 and 1. Okay, then we're going to go hydrogen, we have 1 and 2 hydrogen on the reactant side. We have 2 on the product side. Isn't that lovely? We've got 3 oxygen on the reactant side. 2 plus 1 is 3. We have 3 oxygens on the product side. So everything's balanced. Now let's check our charge. On the reactant side, we only have a +1. On the product side, we have no charges. Okay, so here, which side is more positive? The +1. So what we're going to do is we're going to add an electron to this side. I'm just going to add it right there. We only need to add 1 electron because a +1 and a -1 equals 0. So remember, +1 minus 1 equals 0. Okay. Then let's do the other half reaction. This is the one that's oxidized. So sulfur, we have 1 and 1. That works out nicely. Then we've got 2 hydrogens. On this side, we have 2 plus 1 is 3. So that's not going to work. So let's go ahead and add a 2 to this side. We're just going to increase it by 1. And that's the only place that has hydrogen is that water on the reactant side. So then on the product side, how can we make this 4? We already have 2 here. We have 1 here on the hydrogen ions. Let's go ahead and add a 2 here, because if we add it to the sulfuric acid, it's going to change things. It's going to change the other substances. So we're just going to add that. So now we have 2 times 2 is 4 hydrogen. 2 plus 2 is 4 hydrogen. Okay, and now hopefully the oxygen will work. Okay, here we have 2 oxygen plus 2, so we have a total of 4. Over here we have 4. So now that's balanced. Okay, let's look at our charge. On the reactant side, notice there's no charge. There's no charge here, there's no charge here, no charge. On the product side, we have a 2 coefficient and a +1, so we're going to get a +2 on this side. So again, which side is the most positive? The reactant side with +2. How many electrons do we need to add to make it equal 0? We need to add 2. So we're going to go ahead and add 2 electrons right there. Okay, I'm going to clean this up a little bit because it's looking pretty crazy. I'll try my best, except now I just erased things I should not have erased. Okay, so now right here we had an electron here, remember? Okay, and on this side we had 2 and 2 for our coefficient. Okay, now let's look at our electrons. Are they the same for both half reactions? On the left half reaction, we only have 1 electron. On the right, we have 2. So we're going to multiply this entire reduced half reaction by 2. Okay, by 2. Okay, when we do that, we get 2 HNO3 plus 2 hydrogen ion plus 2 electrons. Then on the product side, we get 2 NO2 plus 2 waters. Okay, that 2 is going to distribute to everything behind it. Okay, now we're going to go ahead and I'm going to rewrite the oxidation half reaction underneath the reduction, and we're going to be able to cancel things out. So I'm going to stick my arrow here. We have SO2 plus 2H2O, and that's going to go to H2SO4 plus 2 hydrogen ions plus 2 electrons. Okay, now we're going to combine these. We're going to cancel out anything that is the same but on opposite sides, so like a reactant and a product, and they have to be in different half reactions. So right here, notice how we have 2 electrons, 2 electrons. That's the whole point of making our electrons the same. Okay, and then anything else that's the same we can either reduce or cancel, or you can leave it alone. So for example, we have 2 hydrogen ions and 2 hydrogen ions. One's on the reactant side, one's on the product side, different half reactions, they can be canceled. Okay, the same thing happens with water. We've got 2 waters on the product side, 2 on the reactant side, those can be canceled. If they're not the same amount, they can be reduced. Okay, now is there anything else that's the same? Nope, so let's go ahead and rewrite our equation. So we're going to do 2 HNO3 plus SO2, and that's going to give us 2 NO2 plus H2SO4. Okay, let's double check and make sure that we have this correct. So first of all, we've got 2 hydrogen. That looks lovely. And then we have 2 nitrogen, because remember that foils to everything behind it. 2 nitrogen, so that's good. Then we have 2 times 3, we have 6 oxygen, plus 2, we have 8 total. Then over here we've got 2 times 2 is 4, plus 4, so 8 on both sides. Whew, I'm so glad. Oxygen is usually the hardest thing. And then last but not least is sulfur with 1 on the reactant side and 1 on the product side. And then our overall charge, there's no charge on the reactant side, no charge on the product side, so this would be our overall reaction. Right here, just kind of erase that. Okay, overall reaction right there.